So this is the second session in the second track for Android Study Jams. This is today's schedule. It's a pretty short session. We'll be covering pathway 5 and 6 today. And so let's just have a quick recap of last time. So last time was mostly a recap of track 1 in itself. We just again looked at Android Studio views, layouts, view binding. But the one thing we did look at that was completely new was something known as navigation. For anyone who's missed it or hasn't had time to watch the recording of last time, just quickly, it's basically moving through multiple screens instead of using intents, which is how you normally do it or used to do it before navigation came along. Navigation is basically a library that the Android team developed, and it offers many more features as compared to plain old intents. As you can see here, this is something known as the navigation graph, where basically you drop in fragments, which are like sub-activities or smaller activities. That's the best way to describe them. And you can define directions between fragments. So here you can see this one leads to this one, and this one, it also leads to this one, and this fragment leads to this one, and this one leads to this one. So in that sense, you can create kind of like a whole journey for your app, and you can decide how to navigate the user base, meaning if they press a button or if they type something specific, or if they touch a floating action button or things like that. And it also offers inbuilt integration for inbuilt code for the most common navigation patterns, such as the back button or the navigation drawer, or which is the three little vertical dots you see often in apps, or even the hamburger menu, which is the three horizontal lines you see, and also the back button. We also looked at something called backstack, which is, if any of you have already dealt with data structure, it functions like a normal stack. Basically, you push in the most recently visited screens and pop them off once the user goes back to the previous screen. For anyone who's not familiar with data structures, think of a stack as like a pile of books where you place one on top of each other, and you can only access the recently placed one. So in this case, for the app, our books would be replaced by screens. So if you open any app, the home screen would be the first on the stack. And as you move through stacks, the pages would get added onto the stack. And if you click the back button at any point, the recently visited page gets removed. With navigation, what you can do is you can control how many screens get popped or screens get removed from the stack when you press a back button. So last time, as an example of this, we looked at the Android trivia app, where basically you played through a bunch of questions, and once you reach either the game over screen or the game win screen, if you press back, you'd have to go all the way back to the beginning screen and not the last question you attempted, which is incorrect. So in that case, it would help to pop all the pages you visited in between, and that's where navigation helps. The way you do all this is, surprisingly, you don't have to write you have to write very minimal code or no code at all, and you can connect all this and include all this popping mechanisms through something known as the navigation graph. It's just like the layout editor for screens. While the layout editor helps us design the screens, navigation graph helps us plan all these directions and setting the pop action for each page. So let's get started with today's section. Like I said before, we'll be looking at two pathways, and we'll be looking at the Desert Clicker app and the Guess the Word app. So these are the two apps we'll be looking at today. After today, you'll be able to, these are some of the learning objectives for today's session, them being identifying different stages of an app, getting more information about your app in the console, modeling your app in a certain way to make a lot of things easier, not necessarily in a programmatic way, but it helps with maintaining your code, readability of your code, and we have a saying in the programming world that you'll be reading your code more than writing it. So maybe you've worked on a project for a while and you stop and come back, you'll have more sense of your app if you follow certain guidelines and follow certain structure for your app, which we'll look at later on. And lastly, when you have certain data displayed on your screen and the data changes in the database or wherever the data is stored, you can immediately get notified of it, and that field will change automatically as well. Right, so the first thing we'll be looking at today are life cycles. And as you can see from the image on the light, or even the title for the slide, it's the circle of life for an app. So just like different organisms have life cycles from all the way from life to the death, they go through different stages. Android apps have their own life cycles too. Actually, that's not completely correct. When I say app, I mean each of the fragment or activity. So you can say that an app is made up of multiple fragments or activities. And in that sense, each of these activities or fragments have their own life cycles. And in that sense, collectively, you can say that a whole app has its own life cycle. So right from when the user opens the app, the life cycle starts. And as you go through the screens, an activity changes state, which basically means it kicks in another stage of the life cycle. And an interesting thing you can do is actually in your code, you can execute certain code when a certain life cycle stage is reached. So suppose when the user exits the app, we have a certain stage in life cycle for that. You can write some code, or immediately when the user opens the app, you can write some other code. And this is done with what's known as a callback, which we'll look at now. So a callback is basically passing around functions. Uh, People who are coming from Java, you know that Java is an object-oriented program where everything is treated as an object. But Kotlin and JavaScript, they have something known as functional programming. It's another programming model, just like object-oriented programming, with one very fundamental change. It's that everything is a function, not an object anymore. So you can assign functions to variables, pass them as arguments into other functions, and even return them from other functions. So it's just like a variable and an object you do it in object-oriented programming, except this time it's with functions. And like I said before, Kotlin allows this, and that's exactly what callbacks are: functions passed as argument on other functions. And normally in JavaScript and all, if any of you are familiar with JavaScript, the set timeout function is a example of a callback function, because along with the amount of time you set to suspend the code for, you can actually pass in the code as a parameter as well, and that's basically a function. And unlike in JavaScript or other places in Kotlin, we don't have to explicitly call these callbacks. Android calls them upon it, it will automatically detect the state of the activity and passes these callbacks automatically. So here we look at the activity lifecycle, and later on we'll look at the fragment lifecycle also. As you can see, it has any activity has basically 5 stages in the life cycle. One is obviously when you start, and resumed, created, initialized, and destroyed. And you can see here what look to be function names, and that's exactly what they are. Excuse me. On resume, on pause, on create, on destroy, on start, on restart, on stop. All of them are callback functions. Now, a small question. Have we come across any of these functions up till now in the course? Uh, yeah, can you detail which one? Yeah, what's the function name? Can you recall? Yep, that's exactly right. Thank you, Prashanti. It's on create. Yeah, so just like in Java, you have a main function And in Kotlin, you have to have, again, a main function. In Android, every activity has to have an onCreate function. It's the rule, because that's what happens when that's the initial setup for the app when you start the activity. So it's like you could think of it as a constructor and an object wherein you pass in a couple of parameters to set up the object and have certain properties ready. Similarly, onCreate is something that's called right when the activity is brought into focus, and whatever code you write there gets executed. So we've been doing this for all of this course now. It's just that we haven't built any concrete concept around it, and now we have, so hopefully you have a better idea of what that function means. Next is logging. It's the huge cause for one of the biggest causes for deforestation. It's the act of cutting down trees, and the cut down trees as the wood is sold, and there are different methods of logging. One of them being tree length, then you have whole tree, then you have cut to length. And it's considered to be a dangerous occupation because of the obvious dangers involved. A tree could fall on you, you could cut yourself on one of the tools, or you can even get splinters. So that's what logging is. Let's move on. Oh, have I been talking about? Oh, my bad. I'm so sorry. I didn't mean to talk about this. Uh, right. Yes, this is the logging we're looking for. So, sorry guys. So this is actual logging that we'll be looking at. This is what's relevant to us. So logging basically means writing or printing messages to the console. And what the console is just, it's a inbuilt or default tool or part of the any IDE you download or any software you download to write code. It's where your output is seen. So in Java or Kotlin, when we looked at the Kotlin playground, even that had a console where it printed out the output. And that's what the console is. So logging basically writes and prints messages to the console. Now, this sounds familiar. Is there any other? I think there's another function that does this, if I'm not wrong. Can any one of you uh, quickly recollect if there's any other function that does the same thing as logging? And if so, what the function is? No, Toast prints to the app itself. I'm talking about the console in the editor. Like in Java or Kotlin, any of the IDEs we've worked with, I'm not sure. I think there's another function that writes or prints messages to the console. Uh, maybe you want to have another go at it. Okay, so the print function does that in Kotlin and Java. In Java, it's system.out.println. In Kotlin, it's just print. So then you must be wondering, what's the difference between both? Why use logging when you already have a perfectly good function for doing what I'm saying Kotlin does, or what I'm saying logging does? Well, turns out it's a bit more deeper than that. That's not all that logging does. When you want to debug, which is basically the process of finding out the source of an error and removing that source or removing the error, you might have a lot of statements. You want to check where something is going wrong, or at what point in the program does the code not go past, or something like that. You might end up putting up a lot of uh, messages in there, and if you put so many, especially with Android, which prints other messages to the console, your debugging messages might get lost if you use the standard printing function. With the logging, at least in Android, there's a separate tab for it, called logcat, as you can see here. And in logcat, you can filter out the logging messages for each activity and for each fragment. And you can even filter them out by the type of log messages, which I'll talk about now. There are a couple of different types of logging messages. One is information, one is debug, one is verbose, one is error, and the other one is a warning. Now, information, as you can probably guess, is just standard information. Like you can see here in the screenshot, we're printing out on create has been called. So that's the message. So this will probably be printed after inside the on create function. And debug is when you just want to, you can say that there's no real distinction between these messages. There's no specialty to them. It's just that you know what you're looking for and you can filter them, like I said before, by the type of messages. So you have I slash, and I here stands for information. So you can, you have the function known as log, which is what prints the message. And in that log, you'll have to call different sub methods. Like if you do log.i, then you're calling the information message. If you do log.d, you're calling debug, so on and so forth. So here are the different lifecycle methods we have in an activity. Like I said, there are a couple more than what was in the image. So quickly, on create is when the activity is started, and on start is when an activity is being shown again or called along with on create, and it's followed by on resume. So often you must have experienced this when you want to share something from WhatsApp, or you want to open something from WhatsApp, you'll have another screen open up saying where do you want to, how do you want to share, or which app do you want to use to view the picture or document. So in that situation, you can still see the background, which is your chat or your WhatsApp screen, but it's not in focus. So technically that activity isn't there. What is there or what's in focus is that little pop-up at the bottom. So when you close it, your chat activity becomes visible again. So that's when on resume is called, and immediately after that on start is called. So again, following the same example, on pause is called when the user is no longer interacting with the screen, but still can be seen. So like I mentioned just in the example, you can still see your chat screen, but you can't interact with it. So that chat active will be paused. And on restart is suppose when you're open your WhatsApp and you have the list of users. That's one activity. And when you go to one of the specific chats and come back outside, you're going back to that same screen again. So that's when on restart would be called. And on resume, like I said, is when activity is ready for user interaction and is visible again completely. Meaning in the case of the WhatsApp again, when you close down that pop-up for choosing the app to share, the chat activity is fully visible and you can interact with it again. So in that case, on resume is called, and tying back to the second activity, on start is called immediately after on resume. On stop is when the activity is no longer visible to the user. In the case of switching from one chat to the other chat, the previous chat won't be visible, neither will the list of chats. So those two activities have been stopped. And on destroy is basically when you exit the app for good, all the cleanup for any activity required. Maybe you've set some memory, or you allocated some memory, or you've declared some variables and you don't want it to get clogged up in memory for no reason. All that stuff you can clean up in this method. Now, one thing you might notice is that we don't really use any of these methods. We don't override them, or we don't write separate code for them. And that's because we don't really need to. Like I said before, Android automatically calls these methods. It knows when or when particular activity or fragment is going through a certain change, and based on that, it will automatically call these uh, methods. So the only one we really need to worry about is on create, because that's when most of our code is being executed. And in the case we do need to provide some specific code for any of these functions, we can always override them. And yeah, that's for the pathway 5. So we look at both the code labs. First, we look at code lab 1. Yeah, so for this code lab, we'll be looking at the desert clicker app, which basically you can tap on the desert on screen, and it will add to your total amount. And if you click a particular desert enough number of times, it will change to another desert with a different price. And you can continue clicking and the price will keep on adding up. So this looks at the lifecycle methods. Like I said, again, it's just the different stages an app can go through when certain things are happening to it or when certain things aren't happening to it. So activity is a class. Also, it's a concept in Android and it's a class itself. And any subclass of activity that you might extend from for a fragment, they all implement a set of lifecycle methods automatically. And Android, like I said, again and again, time again, it calls these callbacks automatically when the situation demands it. We looked at an activity lifecycle. This is a fragment lifecycle. It's very similar to it. It's in fact the same, but it's callback on slightly different occasions. You have a couple more callback methods, as you can see here, on attach and on detach. And yeah, that's about it. You can explore them later on. So yeah, you can see here the class main activity is being extended from app compact activity, and this is a subclass of activity. So as the Codelab said, this main activity will implement all these callback methods such apart from on create, and we can override them if you want to. We don't have to, either way, it's fine. So yeah, this is the on create method. Like and yeah, like I mentioned, you have the log method, which is what helps you write messages to the log cat. And if you you can call different types of logging messages by calling different dot methods using the dot way of calling methods. You can do log.i, which will create a information message. You can do log.v, which will create a verbose message, so on and so forth. So there are two parameters to this. One is known as a tag, which basically tells you you're assigning it tag, so in such that if you can filter by it. So if you do log.i in brackets whatever activity you're in the logcat you can filter by that particular activity. So you're kind of grouping all the messages from one activity under one class, so that the logcat knows that you can filter by this class as well. And then next, we talked about the onStart method, and often it's coupled with an onStop method, obviously. So if you start, you'll have to define the code for stopping as well. It's not necessarily you can do it if you want to, but it's just better to do both because you're opening one door in one sense, you might as well close it. And this whole exercise is just basically logging in different places and seeing what is called when in what situation of the app, when you open it, when you switch activities, when you click something, other situations also. Timber is a library for logging. It You have to add it externally. It doesn't come with the standard project in Android Studio. So you can use Timber, and it has certain advantages, but for me at least, I don't think I used it till now. Like I can stick with the normal log method and that'd be fine, but you can explore more on it and maybe you'll find something that you like there and you can use that as well instead of the logging method. So again, they've just implemented each of the callback methods just to see when each of these methods is called, and you can do the same. Yeah, so once we've done that, you can open and close the activity, and then you'll see that on create and on start, they both are always called as a bundle. Although once you go back to method, on create is called only once during the lifetime of your app. from when you open it to when you close it, it'll always be called only once, and when that's the whole thing starts, or when the activity starts. But if you go back to the activity or bring it out of focus, take it out of focus and bring it into focus again, then only onStart will be called, not onCreate. But if onCreate is called, then onStart will be called also. Yeah, so this is what I was talking about by partially hiding the activity or taking it out of focus. So here you can see that the share message dialog has popped up, and in the background you can see the Does It Clicker app. Currently that activity, the main activity, is not in focus, and what this means is that you'll call the onPause method for that activity, and when you pull down this method or you dismiss this pop-up box, you'll call the onResume method, because in that case the activity will be in focus again. And yeah, again they're doing the same thing with fragments instead of activities. And there, like I said, there are a couple of extra callback methods in fragments. We can go through them quickly. On basic, one thing to keep in mind is that fragments, like I said before, are sub activities or smaller activities, and you have one activity and you can use multiple fragments there, which means that that one activity will swap out different fragments depending on the actions you perform in the app. So if you have the home fragment and you have the home to fragment, once you click a button from home to home or home to, it will swap out the activity will swap out one fragment for the other, and that's what fragments are. So in that sense, each fragment you can say will be associated with an activity. So you can maybe you can have two activities, and each activity can have its own set of fragments attached to it. So for activity 1, you could have fragment 1, 2, 3, and activity 2, you could have fragment 4, 5, 6. And when you're on activity 1 only, you can switch between fragment 1, 2, and 3. And when you maybe one of the buttons on one of these fragments moves you from activity 1 to activity 2, then you can only switch between fragment 4, 5, and 6. So in that sense, each fragment has its own activity, and that's when the onAttach method is called. When you associate the fragment with an activity, that's what Android does internally in the background. Excuse me. And on create view, we have this for the fragment only. Again, it's the fragment specific callback, not specific to activity. Is when you inflate the fragment with its view from the layout editor. And on view created, like on start is with on create, on view created is coupled with on create view. It's called immediately after. And like on start, on view created is called when the fragment comes into focus, but on create view is only called once when the fragment initially appears. And if you have on create view, you have a pairing method which is on destroy view. And yeah. So now this whole Codelab is looking at more complex situations where you have many stages to go through, or other stages could come in, and seeing when they trigger and trying to simulate certain situations where these stages could kick in. The main one is app shutdown, basically when uh, so when you open up app in Android, when you open up a couple of apps and you switch from one app to another app, you'll notice that those apps go to the background. So you can long press on your home screen and you'll see a collection of the apps, or even press the square button on the bottom and you'll see a collection of all the apps in the background. So when this happens, it's not destroyed, it's all the activities are put on stopped, and once you focus the app again, on resume will be called for the latest activity you had when you left the app originally. But suppose if you're using an app that requires heavy focus, let's say you're playing a really high-end game or you're using the GPS app, both these require a lot of resources from the Android OS. And let's say you have maybe a calculator app or a phone app in the background. Android might shut down those two apps forcefully just to keep whatever app is in the focus right now running smoothly. So in that case, let's say in the calculator app, you just perform some calculation, 2 plus 3 equals 5, and you left it in the background. So normally what would happen is if you went into the app from the background, you would still see that calculation. But in this case, when Android decides that it needs more resources to run your intensive app more smoothly, and it can't do that with having these apps in the background, it might shut down the app. And in that case, your calculation or the data you have on the app you left in the background might be lost. So if you do that, once you exit this high intense app and go to the calculator app, you won't see the last calculation you performed because Android shut it down. And the default thing to do is when an app shuts down is clear everything, because that's the whole point of shutting down an app. So you free up some resources. And this might be okay in a simple app like maybe the calculator app or some calendar app that you're marking an event or something like that. But if you have some data that you really need to keep track of and you haven't saved it yet for whatever reason, if it's shut down, then the data is gone and you can't recollect it or bring it back. So what happens in that case? How do you make sure, what assurance do you have that that data you put up in the app is safe? And that's where this method on save instance state comes in. You can call this in any one of the fragment methods, sorry, lifecycle methods or activity methods. Uh, it's a method you can override it. So basically what happens is once this is called, you can save the data you have in your app previously, and once you bring it back, you can perform write another piece of code to restore the state of your app as it was previously. So obviously once you destroy it or shut down it, you'll call the on saved instance method, and once you enter the app again, or once the on create method is started or executed, then you can restore this data from whatever you saved in the on saved instance method. And that's actually what this parameter is. We can see it here itself. So in the case that you have some data that you might need, that you'll need again when you open the app, you can use this, take care of this parameter and use it to bring back any things that you might have lost when the app shut down by mistake or accidentally. So in this case, what we're doing is basically getting certain stuff like the amount of desserts sold, or the price that the app has accumulated up to that point before it was shut down. And there are certain commands you can run or certain things you can click in the Android Studio app to Android Studio software to simulate a shutdown, and you can explore this later on. Another thing that could cause loss of data is configuration changes. When I mean configuration changes, I mean with respect to your device's position. So if you rotate your device, you know that you have a auto rotate method, and if you tilt your device enough, it will change. It will become horizontal or instead of vertical, and that could also cause loss in data. What actually happens then, I will see this later on, is that the fragment is destroyed and recreated. So in that case, whatever data that fragment was holding up to that point is gone. So you can do the same thing, or you can do a similar thing to make sure that this doesn't happen. You can use the saved instance method to keep track of data, and once the fragment is created again, you can bring it back. And that's it for these two Codelabs. So up till now, we just talked about life cycles, which is the stages an app can go through with respect to its activities or fragments. And we briefly talked about logging, the programming kind, not the tree kind. So now we look at something a bit more interesting and consequently a bit more complicated, but hopefully I've made it simple enough for you guys to understand and explore more. One of the objectives I mentioned at the beginning was writing your code better. When I say better, what does that mean? It basically means organizing your code. Uh, Oftentimes, when we're just starting out doing projects of our own, we tend to just create the files and leave them there. And when you open the code a couple of months later, let's be honest, that's what happens. We'll work on a project very passionately, stop halfway through, and come back, God knows how long later, and we'll be very confused about what we're looking at. We won't know what we've written ourselves. It's all codes all over the place. We have too many comments or no comments at all, and you don't know what goes where, what each thing, each activity or each file is for, and it's all a very big hassle. We can't get rid of all of that confusion, but we can try, and that's where app architecture comes in. Architecture, the literal English meaning, is basically designing the design of a certain establishment or anything really. Architecture, if you look at it from the literal meaning, it's just the design for a house or design for any building you want to construct and all that basically building the blueprint. We can apply the same concept to apps, at least Android apps, and try to get some benefit from it, and that it will help us and anyone else who wants to go through our code and maintain it. So like I said, it makes it easier to work with, maintain, and for others to read as well and collaborate. And that, as you can imagine, that has its own set of benefits. So it's a very obviously a very useful thing to follow. But how do we get started? Well, basically, uh, instead of just making up a bunch of files with and naming it however you want or what you feel is best, there are certain conventions to follow or certain things you can do, certain folders you can make or packages, like I talked about in one of the earlier sessions. You can make and drop things in the respective packages, so that when someone opens your code or you yourself open your code and go through the packages and the files under them, you immediately know what is what and can guess at least correctly most of it what each file does. And that's what app architecture helps us follow. And as with anything that is designed to make your life easy, there are certain guidelines to follow, there are certain ways you can do it. And similarly, Android app architecture has certain guidelines and different patterns available. Three of the most commonly used patterns are MVC, MVP, and MVVM. MVC stands for Model View Controller, MVP stands for Model View Presenter, and MVVM stands for Model View Model. We'll be focusing on the third one today, but of course you can go out and use MVC, explore MVC and MVP. Actually, MVC is more often used in web as far as I've used myself or seen anywhere else. So that's where MVC is most often used. In full stack projects, you split up each part of the front end and then back end into one of these things and work on that. So architecture is not only app architecture or code architecture is not only present in Android app development, it's in other programming aspects as well. So what is model view model? Well, basically, as you can guess, there are three parts to it: model, view, and view model. So we look at each of them separately now, and if you have any doubts, please feel free to ask. I'll stop and explain again or clear your doubt. So with that in mind, let's get started. Actually, before we go ahead, does anyone have any doubts on the previous pathway concepts? All right, cool. So first up, I know it says model view model, but I think it's best to go down like as in the picture here. So I'll explain it from view model, then model. So what is a view? View basically contains the code for displaying the UI components and handling the UI triggered events. That's all it does. So when you think of all the fragment.kt files or activity.kt files, those are all views because all they contain is you're accessing the components from the layouts and displaying them on the screen. And if required, you're handling the events. Suppose if someone clicks a button, what should happen? If someone clicks a text, what happens? Or if someone types an input field, what happens? Or if someone clicks on an image, what happens? That's all you're doing. You don't you don't control what is displayed there, or you don't control how much of something is displayed there, and you don't perform any business logic. Business logic being, suppose you have, let's say you have something like Teams or WhatsApp or even YouTube. Each of these apps is specific for different users. Like different users have different contents. So if I open up my Teams app and go to my calendar, there'll be certain logic to show me what all meetings I have planned for the day. Or if I go to my Teams tab, I'll see what teams are channels I'm part of. That code, or if you that code to show me what, to decide what to show, what teams should appear for me, is not handled in the view. If you look at any of the activities we've coded till now, or any of the fragments we've coded till now, we've never decided what goes on the page. It's only the components and what happens when any of the component is clicked. That's all that there is to a view. It's very simplistic. It's just to show you what's on the screen and what should happen when you click. Things like for this person they should appear, or for this page they should appear, none of that is decided in the view. It's all left up to the other two components, which we'll talk about now. Next up is the view model. So like I said, view doesn't have the logic to decide what is required to be displayed. And that is up to the view model. So it gets the view model's job is to obtain the data required to be displayed in a view. The source of data, or where it gets the data from, can be through local storage, basically storage on your phone, or remote storage, which would mean some database up in the cloud or some server somewhere. That's the view model's job. Again, just like the view doesn't decide what data should be displayed, the view model has no idea which view it's going to be used, the data, or what layouts that view has. So if there's one view model, it doesn't know if activity 1 is going to use it, activity 2 is going to use it, and frankly, it doesn't need to bother. All it needs to do is keep data ready for a certain view, and once the data is ready, the whatever view needs to use it can use it. And it gets through the data it needs to acquire. It gets through local storage or remote storage. There's something in between known as repository, which I'll touch upon a bit briefly later on. And the model contains all the business logic. So I'll try to, business logic being the logic for deciding what data to get, or what data to limit, not to show, and what to show. I'll try to explain all these, the role of all these three in a simple, a well-known example of an app. So let's take Teams. So let's say I am one of the users of Teams, and let's say one of you guys is one of the users of Teams. So for me, I'll have my own list of assignments and calendars, and the three things need to happen. One, the calendar, when I click the calendar tab, that layout has to be loaded. Two, based on my user ID, the data to be shown there, which is in this case, the meetings to be shown, have to be loaded. So they have to be retrieved, and they have to be stored somewhere, so that when that layout is loaded, that data can be fetched from wherever it's sitting and displayed to me. So here, the view would be loading the layout. If you can remember the calendar layout, it's something like, it's just a blue screen with blocks representing the meetings and the meeting title, and when the meeting starts, a join button. So those components, those are what the view will contain. It will show them, and maybe it will say, it will have an event trigger for the block of meeting. So when you click on the block of meeting, you get a pop-up saying RSVP or edit if you're the owner. And if you click the join button, it will have a event listener or an action listener saying that when the join button is clicked, join the meeting. That's what the views help role is in this channel activity. Next, so the channel will have, let's say, a list of meetings. That's one data object that's required to display on the calendar tab, which is list of meetings. Then it's the meeting title. Then it's the meeting time. And then it's you could say the visibility state of the join button, whether it should be there or shouldn't be there. Although probably you can handle that in the view, I'm just realizing. So yeah, let's remove that and keep just a list of meetings and the meeting title and the meeting duration and meeting time, right? 4 things. So this is what the view model will have. It will have an object contain, it will have a class containing these 4 properties, and you can create kind of objects for each of these properties to get them ready so that the view can load them in. Then finally comes the model. For me, Sunil, my user ID being, let's say it's Sunil or some random number, based on my user ID, I'll have my own list of meetings. And for some other user A or user B, they'll have their own user ID, and for them, they'll have their own list of meetings. So I can't see user A's meetings, and I shouldn't see user A's meetings. That'd be incorrect. And user A can't see user B's, or user B can't see mine. So deciding what list of meetings to show for whom, that's what the model does. This is done through SQL or NoSQL, depending on the database you want to use. You can construct queries to say that get list of meetings for user whose user ID is whatever user ID or username. So that's what the model does. It contains all the business logic, deciding what to show, what not to show, or what to edit, what not to edit, what to delete, what not to delete, and things like that, or even what to insert and what not to insert. So once it's done all that, it gives the final data to the view model. View model stores it there with respect to certain classes it creates, which represent the properties in the view, like I mentioned, the meeting title, meeting author, meeting owner, and meeting edit time and duration. And the view just contains the corresponding UI components. And repository just acts as a mediator between the view model and model. It's not too different from the codes of both of them, as we'll see later on. Just remember that it can act as mediator between getting the data and storing it. So that was all about organizing a code, and one of the architecture patterns available. Uh, Basically, I'll quickly talk about other two also. In the case of MVC, I guess you can probably understand from the name itself. The controller plays the role of the view model, and in MVP, the presenter plays the role of view model. I personally haven't used MVP before, but I have used MVC, and I can say it's very similar to, or exactly the same as what view model does. It just keeps the data ready for you to use, and once you get the data, you can give it up, let the view use it. So oftentimes you'll get, suppose you're subscribed to someone on YouTube and they post a video, you'll get a notification saying that they posted a video. Or let's say you post a comment on any social media platform, YouTube, Instagram, Twitter, Reddit, anything. And initially, let's say your uh, comment has 0 likes, and there'll be a page or an activity where you can view the comment you made and the page the number of likes with the thumb icon and the number next to it. And let's say a couple of people like it. As and when they like it, that number will change, right? So when one person likes it, it'll change to 1. When a couple of thousand people like it, it'll change to 3.5K or 4.5K, something like that. How does this happen? I mean, in the sense, how does it happen? In the sense, it doesn't happen without, you don't have to refresh the page to see the change happen. In real time, as and when somebody likes it, you can see the numbers change there. How does that happen? How can we get that feature in our apps? Well, that's where something known as live data comes in. As you can tell by the name, live means as it's happening, and data is data. So this is what helps us get real-time updates on any of the data we've stored in the app, and consequently we can update the views as well with the same data seamlessly without having to refresh it or start the app again. And there'll be no interruption to the user's experience. It'll be smooth. It'll be like nothing happened. It'll be like loading a new page with different data without actually doing that. So how is this achievable? Well, we use something known as the Android Jetpack library, which is another library that people at Android developed. And a part of it is live data. So one of the components of this library is the live data class. And it's an observable data holder class. That sounds like a mouthful, I know. So let's break it down. First thing is it's observable. which means it observes something. What does it observe? It observes data. And it's a data holder class, like the name suggests, it holds some data. And again, what data we'll see. So what you can do is you can take your live data object and wrap it around some existing data. So let's say we have this, we'll go back to the comments example. And let's say in the app's code, we have a class called comment, and it has a couple of properties. One is the comment description, one is the comment date when the comment was posted, and the comment likes and the comment dislikes, right? So what we can do is we can take an instance of live data and actually wrap it around this object of comment, and whenever any one of the properties of this comment changes, we can set it up such that we get notified and we can update the view accordingly. So we attach in one of our views, we attach an observer to live data, meaning that we're observing this live data object such that whenever it changes, we get notified. And we can wrap it around the whole class or the whole object, or just one specific property of the object. That's up to us. Mostly we do it such that we wrap it around the whole object. So even if one of the property changes, we get notified. But if you do want to, for any reason, stick it to only one property, that's possible as well. So once you do that, once you set an observer up to this live data, that once anything happens, you get notified. You can think of it as a security alarm or a motion sensor alarm. Whenever there's the alarm movement in the proximity, the sensor rings or the alarm sounds. Similarly, whenever there's any change in data, we get notified. And there are certain app functions, callback methods, that on observable or on state changed, things like that, that when your data changes, you can use these, override these methods to perform whatever code or action you want to perform. One more thing is that live data is lifecycle aware, meaning that it knows what stage the app is in, and it can perform certain actions based on that as well if required. So the observers you're attaching to the live data, they come with lifecycle owners. It basically means each activity has a lifecycle, and they kind of own the lifecycle in the sense that they know what stage the lifecycle is in automatically without being prompted, without having to write any code. So that's another thing about live data. And lastly, it only updates started or resumed activities. So if your activity is in the background, or if it's destroyed, or if it's not even there, it won't update. But once that destroyed activity or stopped activity comes into focus, it will become started. So then it will update quickly. So there's no, even with this case, there's no need of being afraid of lagging data or having outdated data on your app's screen. It will always be up to date, and that's the biggest advantage of this part of the Jetpack library. So those are the concepts required for the 4 code labs actually in Pathway 6, and we'll go through each one now. So this app focuses on the guess the word or charades app, where this is the title screen, and basically it's a 2-player game where you try to have your friend guess the word, act out the word, so the friend holding the phone can guess it, and if you get it, you can tap got it and you scroll or increase. If you don't, you can skip it, or you can end the game itself prematurely or whenever you want, and when you do, you take into a score screen where you can see a total score. One thing is all the pathways in track 2 involve starter apps, which basically means they already have some code in them, and they can be found in a GitHub repo, and I'll give the GitHub repo link in the group after the session is over. Or alternatively, you can use the link given at the start of every Codelab. So here they've given the link, and you can go to the GitHub. It takes you to GitHub. You can clone it, or you can directly go to the whole repo, which contains a lot of different stages of the apps we'll be using throughout this track 2, and you can directly download it through zip and extract it and start working with the projects in that sense. So this one particularly, it comes with a couple of bugs. So that's what this focuses on by using the concepts of view model and other things to make sure that you fix these problems. So one of the bugs is that the orientation problem isn't fixed here. So earlier I said that if you rotate your phone, your fragment gets destroyed and recreated, and in that case the current score is lost. And even the app state isn't saved, so probably the on save instance state isn't overwritten yet. So when you close and reopen the app, once you hit the game screen, that score will the game restarts from the beginning. And when you tap the end the game button, nothing happens. So yeah, they didn't use the on-saved instance state. You could fix it by using it and writing your own code. And like I said, we can resolve these issues using the app architecture components we learned about. Again, this is just a very short for you recap of the app architecture. And one new thing that we'll be talking about is, I left it out of the slide so I can talk about it here intentionally, is the view model factory, and we'll see what that is later on. So this picture is also really helpful. It tells you the jobs of a UI controller or view and the view model. So one thing I'd like to clarify: view model just holds the data. It doesn't limit the data, or it doesn't decide what data needs to be showed. That all is done in the model, and that's the model's job. And once that's done, the final data, whatever is required, that is what is stored in the view model, waiting for the view to use it. So here we're just creating an view model for the game class. Okay, so to get over this or to work around this issue of surviving a configuration change or an orientation change instead of losing all the data, we use something called a view model provider. And what a view model provider does is that it returns an existing view model if one already exists. So in the case that, let's say you started the game and you played through a couple of the screens and you won and you end the game, let's say your score is 6. So the data that the score is 6 will be stored in the view model, because the view model will keep track of maybe you're incrementing the score in the view model. So at the end you'll have 6. So what would happen without the view model provider is that once you twist it or turn the phone or tilt the phone and the configuration changes, your fragment will be destroyed and created again. So once it's created again, it will go and fetch from the view model, but that will have been erased because the view model is attached to your fragment. So once that destroyed, this is also gone. So what the view model provider does is that instead of starting things again, if an already existing view model is there, it will return that and doesn't create a new one. So like I said here, if the view model is attached to a fragment, it will remain the same as long as the fragment is alive. So if the fragment is detached from its owner activity or destroyed, then the view model is gone as well. But if, yeah, so that's all this part of the game Codelab is about. You're using the game, creating the game view model class. And the view model, I don't think the view model survives configuration changes. So that's another reason to put your data there, so that once if it turns, you don't have to get it again. With the help of the view model provider, of course, which returns an existing one instead of creating a new one and giving you an empty view model with empty data. And this is, again, you're just moving all the stuff that was previously in the main activity to the view model to be in line with the app architecture guidelines. And this is just refactoring all the code to make sure everything works again. And then finally, lastly, is second to last is implementing a click listener for the endgame button. One of the other problems in the app was when you click the endgame button, nothing happens. So this step in the Codelab fixes that. And the last thing you do in this Codelab is using what's known as a view model factory, which is basically a implementation or manifestation of another design pattern or architecture pattern, you can say, known as the factory method pattern. It's basically a pattern that uses factory methods to create objects, and a factory method is a method that, as you can see here, returns an instance of the same class, which basically means in our case it will return an instance of the view model. So once you add up the score, you can return it through there and display it on your screen. As this was one of the other problems in the app, which that it didn't display the correct screen, just displayed a word. You can read about the view model factory or the factory method pattern here. And this is in this link from the doc from Wikipedia itself. And this again is from Wikipedia. So you can go through, and if you have any doubts, you can always ask. And yeah, as you can see here, you're getting the score through the view model factory from the score view model to show it on the screen. That's about the first Codelab. Now is the second. Oh yes, one more thing I wanted to mention. If you already gone through the Codelabs and you don't see the tick here next to the Codelab, don't worry, this website is a bit buggy. But if you finish the quiz, this progress for your quiz to be tracked, so that's not broken. Once you finish the quiz, you'll get the badge. So you can even see here that the badge has been earned. So don't worry about the ticks on the side of the Codelabs. Earlier there used to be a progress bar, they've removed it, so that's also gone. That's one thing I wanted to mention. And again, always make sure you're signed in to your Codelabs or your pathways to make sure that your quiz progress is tracked as well as your Codelab progress. So let's move on. This Codelab focuses on live data. Basically, you want to change the word and you want to keep track of the score. So I think it shows on the bottom of the screen when you're playing the score. So in that sense, you'd want to update the score as and when you change it. And that's where live data comes in. Now, in the beginning of this whole, both the sessions, both the track sessions, we talked about lists. And there were two types of lists. Can anybody recall the types of lists that we talked about in way back in the beginning of track 1? That's correct. Thank you, Prakash. It's a mutable list and lists. And mutable lists are, can you provide a quick description of what they are and what difference between mutable list and list? Briefly. Yeah, thank you, Prakash and Prashanti. Yeah, mutable lists can be updated or changed. You can delete stuff, add stuff, while lists are only read only. They can only be read and you can't modify them once you initialize them when you put the data in at the beginning. Similarly, in live data, we have two types of live data objects. One is mutable live data and one is live data. So you can probably recognize that this initialization of this syntax is how we initialize lists also. So in that sense, you can think they're similar to lists. You can run them on an object, and they're a mutable live data and live data, like I mentioned. And that's what this whole Codelab is about. It's about using live data to update the score. And this is what I meant about attaching observers. So you have this is a view model, and this is a live data object, and you're attaching an observer to it. And this is what this is the lifecycle owner I talked about. I mentioned that each observable comes with a lifecycle owner, and you pass that in so that the owner or the observer is aware of each of the stages the activity goes through. And you can initialize the uh, observer object, and you pass in this. This is what's known as an arrow function or an anonymous function. Basically, these are functions that don't require any initialization in the sense that you don't need to give them a name or parameters or anything like that. You just take this as the parameter, and whatever comes in, you don't have to specify any type, and you can use it just like any old parameter. So for observers, always you're getting in some data, right? You want to keep track of some data. So that data you pass as a parameter. And like I said before, you don't have to specify any type. It doesn't need any strict typing. You can just name it whatever you want and use it in the correct context, obviously. So here, this is, let's say new score is an int. I think, yeah, it's an int here. So if you but if you use it as an int here, but if you're getting in a string or you're getting in some other incompatible object, you're going to get errors. But you have the flexibility of naming it what you want and using it in the correct context so that your app doesn't throw errors or crash. That's one thing you have to be careful about. Then is just using this live data object in the proper places and refactoring the code to fit this new change of using live data in the app. Yeah, and this is you using again live data to detect a game finished event, basically when the event is done. So either when the word list is empty or when you tap end game, this will be triggered and correspondingly the code has been written. Now we've added live data to the game view model, and now we'll be adding it to the score view model. And lastly is just adding a play again button so it takes you back to the screen. And this is again where the popping the stacks or the back stacks, all the events up to the home screen would come into play. And that's it for this Codelab. Next is code. Quickly, how many of you remember? Oh, sorry. How many of you remember view binding? I'll give you a hint. It has something to do with UI or the layout editor. Okay, quickly, the view binding basically allowed you to access views from your layout editor much more efficiently. The original way was you'd have to initialize every object with a find view by ID function where you'd find out the particular view from your editor using its resource ID, and you'd have to call that method each time. Data view binding fixed that by having you initialize one object called binding object by inflating it with the view, and from that binding object you could access other layout components instead of calling that find view by ID function each time. Data binding is similar in that it reduces communication. You can directly call your event listeners or attach event listeners from the layout itself instead of having to call click listeners in your. So yeah, basically up till now, the views in the XML layout and the view model have been communicating through the UI controller, which is the activity or fragment with click listeners. But with the data binding, we'll remove the connection and let them talk directly. So here you can see with the help of the data binding setup that you'll be doing in this step of the Codelab, you can define another property in the layout itself for any element, with this tag on click, and you can pass in the button, the function defined in your fragment. So you don't have to initialize any click listeners or event listeners. All the button handling or UI component event handling can be done from the layout itself. And as you can see, we're removing all this code. So the view model is the view is even more simplified in that it contains only the data components to display. And then now to take things to another level, to this data binding, you're adding on live data. So basically, since we introduced the change of live data binding, we'll have to refactor our code to make sure it still runs smoothly and correctly. So that's what this is about. And that's it for the third Codelab. Now the final Codelab, the fourth Codelab and the final Codelab in pathway 6. Right, so up till now, the game is such that you can end the game whenever you want by pressing the end game button. But here we're changing things up, much like an actual charades app or a charades game. We'll be adding a timer, a countdown timer, and when the timer runs out, the game finishes. So we have two methods of ending the game. So uh, obviously the timer will change and you have to display that time on the screen. So you use live data. But what type of live data do you think would be best for this job? Anybody, what type of the two types of live data objects we have, which one do you think is best for keeping track of the time left on the screen? Because mutable live data is the only type of live data that allows change or updating the value existing. But yeah, thank you, Sneha, that's correct. So to update the timer will change the values. So to do that, we'll be using mutable live data, and there'll be a variable called current time that you can keep track of the time left or the time to display. So this is all about adding the timer. And the last thing, so to get the time, you'll do something like taking the system time and like setting an amount of time, let's say 5 minutes, or tracking that with the help of system time, like saying keeping track of the time when you started the counter timer and the time left to display the amount of time. And library transformation is basically formatting the date or the time into readable object. So obviously you wouldn't want year, month, and day appearing in the screen. We just want the amount of minutes and seconds left. So that's what transformation helps you with. And in the end, it will look like this. So that's all for the session. And we have the quiz at the last. So it's not a particularly hard quiz. Again, if you get stuck or if you keep getting errors or wrong answers, please go back and go to the pathway again. So I've been asking questions all evening. Any of you guys have any questions, you can leave them in the chat. I'll just talk about a couple of things extra, and if you have any doubts in the middle, you can ask. So I talked about this last time also. This is a program by Google or a competition you could think of, where you have to focus on building a solution for one of the UN Sustainable Development Goals. It's Solution Challenge 2021. Here are some of the links that you'll find useful. The Solution Challenge website contains all the timeline and certain videos that are useful for helping you to help you get started on this challenge and forming a team and all that. There's still quite a bit of time left, and we'll be holding a session soon on it, hopefully, so you can get more clarity there. And in the meantime, also, you can go to these links and look at all the goals that are available and see which ones you would like to work on. Now, one more thing, guys, we're coming out with the recordings of the sessions on YouTube and stuff. So if you like them or if you find them helpful, please subscribe and like, and all the other social links we have are in the group description as well. So be sure to follow our pages. And as you go through the course, any badges you earn in the developer profile or the apps you've made it, you can share with this hashtag and tag us as well, DSC-ASEB. And these are some of the links you can use to continue learning. Thank you so much. See you next week.